Hello everyone, welcome to my contribution of this year's Azure Back to School. In the next 45 to 50 minutes, I want to tell you everything you need to know about the hosting of your Azure DevOps agents. So if you take a look at the agenda, first I want to explain what Azure Pipeline Agents are, why we need them. Then we're going to take a look at Microsoft hosted agents, also on self-hosted agents. We're going to compare them, when to use which one. And at the end, we're going to look at Managed DevOps Pools, which is a fairly new service, which is amazing and makes it way easier for us to host our own agents. If you're interested in the slides, I will post a link down in the description, or you can scan the QR code and you will find them on my GitHub page. Before I get started, a couple sentences about myself. My name is Wolfgang Ofner. I'm a freelance cloud architect. I'm based in Toronto, Canada, and I focus on Azure, especially on architecture, security, and governance, as well as Kubernetes and DevOps. If you have any questions, feel free to comment in the comment section down below or send me a message on LinkedIn. And if you're interested in this content, I post weekly on my blog and also here on the YouTube channel. With this said, now let's get started. So the first topic I want to talk about is, why do we even need pipeline agents and what do they do for us? So the main reason why we need the agents is we want to automate everything. This means if I'm using, for example, Visual Studio and I press F5, then it takes a couple seconds and my software runs. But in the background, there's a lot going on. For example, Visual Studio, if I'm using .NET, will download the NuGet packages, it will do a build, a publish, maybe it runs some tests. And with pipeline agents, I can automate all of these processes. This means the main reason why we have agents is to execute some code. As I said, this can be publishing our application, running unit tests, or just executing any kind of script. So the sky is the limit. We can do literally anything we want. That said, we need some tools to do everything we want. For example, if I wanted to build a .NET application, I have to have the .NET SDK installed on my agent. The same as if I want to run PowerShell, I need PowerShell installed. One of the reasons why I'm using pipeline agents and why I want to automate it is it's fast. Especially if I have a big environment, I just press one button, run the agent or the pipeline, and it will run a script. I don't have to follow a long checklist, I can't forget anything. And if I run it again, it's executing the same code again. So it's repeatable for as long as I want it. An example could be at the end of the Scrum sprint, you deploy your new version, you find a bug, you fix the bug, and then you deploy it again. So with a pipeline, you just press a button and deploy the new version. You don't have to care much about the deployment. Another reason why agents are great, or pipelines in general, is you have an audit log. This means if I have GitHub, Azure DevOps, GitLab, doesn't matter what tool you use, I see what pipeline was executed, when it was executed, who started the pipeline, and what did the pipeline do. So in this case, I have a perfect audit log, and if something went wrong or something doesn't work, I can go back and see what was deployed, and so I can figure out what was broken. With this said, now let's take a look at the differences between Microsoft hosted agents and self-hosted agents. So first, we're going to take a look at Microsoft hosted agents. As the name already suggests, with Microsoft hosted agents, Microsoft takes care of the hosting, and I don't have to do anything. And with this version of the agents, Microsoft offers Ubuntu, Windows, and macOS agents. And the main reason why I would use these agents is it's so easy to use. If I have a small project or just want to get started, it only takes a couple lines of code. So if you take a look here on the right, we can see we have here our pipeline, and I have 3 jobs. And all you have to do is provide the VM image, and then you say what image you want. For example, on the top here, we say the VM image is Ubuntu latest, and this means we're using the latest version of Ubuntu. Further down with the same for macOS and also for Windows all the way on the bottom. That's all I have to do. After this, I can already start writing my pipeline and it will automatically picked up by an agent from Microsoft and then executed. Another advantage of having the Microsoft agent is it already comes with pre-installed software. So all the commonly used software like .NET, Java, Python, but also PowerShell, kubectl, Docker is already installed on the agents. And also Microsoft takes care of the updates. This means I don't have to do any maintenance work. I just use it. And lastly, it's very cost effective, especially for a small team or if I just want to try something out. We're going to talk about the costs in a minute, but for a small team, it might be even free to use it if you don't use it too much. And especially for students, since we are talking about back to school, you have enough minutes to run per month, so you can use it for free. The Microsoft hosted agents are great because Microsoft takes care of everything, but it also comes with some limitations. The first one is every time you have a new job in your pipeline, a new agent will be created. This means there's a little bit of downtime in between jobs because a new agent is being created and you also don't have any caching. It can be a good or bad thing depending on what you want to do. But for example, if you're using Docker, you build a Docker image, it takes a couple minutes and then in the next step you can't reuse it. You have to build it again and therefore your pipeline will run for longer. Then I said the agents come with pre-installed software, which is an advantage, but it can also be a disadvantage. Since you don't have control over what software is installed, if you have something a bit more exotic, you might not be able to use it. If you can install it using the command line, then you can use it, but there's some software out there where you have to have a UI and then you can't use the Microsoft hosted agents. Also, since Microsoft takes care of everything, they only provide a certain amount of resources. This means all agents only have 2 CPU cores, 7 GB of RAM and 14 GB of SSD disk. For the macOS, I think you have 3 cores and 14 GB of RAM, but it's still not a lot. If you want to build a big project that needs a lot of resources, it might take quite a long time with the Microsoft hosted agents. And there's also no option to increase the amount. So either you stick with that or you go to the self-hosted agents, which we'll see in a couple minutes. And from a security perspective, one of the downsides is you can't integrate the Microsoft hosted agent into your own network. The Microsoft hosted agent connects over the internet to your resources, and therefore you have to have it available on the internet. So from a security perspective, it would be nice to have it inside your network and completely shut off the network, but that's unfortunately not possible with the Microsoft hosted agents. So that's something you have to consider when you select what kind of agent you want to use. The last downside is we have a limited execution time. This means if you're using the free version, we can run a pipeline for up to 1 hour. After 1 hour, it will just fail. If you're using a public project, then we can run up to 6 hours. And also if you have a paid version, then we can run up to 6 hours. This brings us to the costs of the Microsoft hosted agents. So every Azure DevOps project gets 1 agent with 1,800 minutes per month for free. That's why I said, as a student or if you're a small team, this might be already enough to get started and to use it, and you don't have to pay anything. And then there's a bit of a specific way Azure DevOps does the licensing. And the way it works is you don't buy more agents, you buy parallel jobs. This means how many jobs can you execute at the same time. In Azure DevOps with Microsoft hosted agent, a parallel job costs $40 per month. And with this parallel job, you also get 1 agent. This means if you have 3 parallel jobs, you also have 3 agents and can run 3 pipeline jobs at the same time. What's also a bit specific is the first agent you buy is only to buy unlimited minutes. You don't get an additional agent. So the first one is to have unlimited minutes for the one you already have. And from the second one you have again unlimited minutes, but get an additional agent. If you're running a public project on Azure DevOps, you get 10 agents for free, and they also have unlimited time you can use them. So with this out of the way, now let's take a look at self-hosted agents. And they're a bit simplified, almost the complete opposite of Microsoft hosted agents. Whereas Microsoft took care of everything with the Microsoft hosted agents, we take care of everything. This means we have full control over the agent. We can decide what software we want to install, where to run the agent, how to integrate it, and so on. This means as a developer, I have full control over it. So if especially I have some exotic software, I can just connect to my agent, install it, and then use it. And also with the resources, I can use any hardware I want. I can install it on my developer machine, or I can install it on a massive server and use this one. Whatever I need, I can use. Another advantage is I don't have a limit with the execution time. So if I run, for example, nightly jobs that do a lot of integration testing, complicated calculations, I can just run them, and it takes as long as it takes. From a security perspective, I can easily integrate the agent into my own network since I install it on my own hardware. And this means the agent can connect to other resources over a prior connection. As a result, I don't have to have my resources available on the internet, and therefore they're potentially safer or more secure. Lastly, as with the Microsoft hosted agents, I can run them on Windows, on Linux, and Mac OS. As with the Microsoft hosted agents, we also have some limitations with the self-hosted agents. And again, that's basically the opposite of the Microsoft hosted agents. There, Microsoft took care of everything. With the self-hosted agents, I have to take care of everything. This means I'm responsible of the maintenance of the operating system, of my agents, of all the software that's installed. If a new version of my software is coming out, for example, in fall, Microsoft will release .NET 10, then I'm responsible to install the .NET 10 SDK. I'm also responsible to install security patches and updates. Also, I'm responsible for the costs of the infrastructure. If I'm having a server just standing around, I can use it, but if I don't have any hardware, I have to buy it or I rent it on the cloud, and I have to pay for that. Another challenge I have is with the scalability. This means I'm responsible to make sure that my developers have enough agents and enough resources. This means if I just use too many resources, my developers will be slowed down. And if I just use too much hardware, then I pay for resources I don't use. Lastly, I'm also responsible for the monitoring. This means if somebody fails, for example, an SSD fails in my agent VM, I'm responsible to monitor this and to fix it. Now, if you take a look at the costs, we get one free parallel job per organization. So that's the same as with the Microsoft hosted agent. And something I forgot to mention before is you also get one free parallel job per Visual Studio Enterprise license. With the Microsoft hosted agents, you also get an additional agent, but with the self-hosted one, we just get the parallel job. And since we are responsible of taking care of the infrastructure and everything, we pay less. And here we pay $15 per parallel job per month. But as I mentioned before, we also have to pay for the infrastructure. So in the end, that's probably the more expensive solution, but it might be the more secure and more efficient solution. And so you have to weigh what's more important for you and what kind of project you're using with it. Now let's take a look at what options we have to host our agents. The first one is how to host them on VMs. This has been the go-to solution for the last, I would say, 20 years. And it's still, if I'm talking to developers and we talk about we need to host our agent, they just think about VM. Because it's very easy. Everyone knows what a VM is. If you're using a cloud, for example in Azure, it takes like 5 mouse clicks and you have a VM running. You have so many tools like VMware to host it locally. So everyone knows it. And yeah, it's the go-to solution. The big advantage is you have full control over the infrastructure. This means I can decide how many resources I want, what operating system, what software should be installed on it. And with the VM, I can just connect to it and install any software I want. If I'm using Windows, I can RDP into it, the same with Linux. Install software that might only be available over UI or something very specific, and it just works. Also, since I'm using the same VM all the time, I can do some caching. This means if I build Docker images, I can already download them, reuse them. If I have like images for machine learning, I can already download them and use them from the SSD. And so it might be way faster than using Microsoft hosted agents. Lastly, I can easily integrate it with my network, since a VM is running in a VNet, no matter if it's on Azure or in my local on-premise data center. I can easily connect from a VM to other resources and do all the deployments I need to. If you're using Azure, there's a functionality called Virtual Machine Scale Set. And here Microsoft takes care that if you need more resources, that Microsoft will just add another VM that's a clone of the original one, and you can just use 2 VMs or as many as you need to run your agents. Also, if you don't need them anymore, Microsoft takes care to delete them, and so you don't have additional costs for not used resources. The problem with this approach is often the hardware is underutilized, especially if you're using it on-prem, because you need a big server usually, because all your teams are usually working from 9 to 5, but during night, weekends, holidays, it's barely used. So it's just standing around and costing you money. Then the infrastructure can be very expensive. If you're running on-premise, you have to buy the full server. This means you have to pay it at once, which can be really expensive. But also if you're on the cloud, VMs are one of the most expensive resources. Even if you scale them down at night, if you don't use them much, it can be quite expensive at the end of the month. If you're using the cloud, you have a VM there, but then you have to find a secure way to access it. By default, you can just RDP or SSH into the VM, but that's not secure because an attacker could also try to get in there. So you have to find a way how to secure it. In Azure, the recommendation is to use Azure Bastion, which is a jump host. This means you connect to Azure Bastion and then over private connection to your Azure VM. It's easy to install, to set up, but it adds additional costs to your solution. Then the next option, a bit more modern option, is to run our agents in a container. So Microsoft provides a Docker file. You can find it in the documentation or also on my GitHub. And with this Docker file, you can install any software you want. You can say what operating system you want, install the software, and set everything up for the agent. So if you take a look at this Docker file, we can see here on the top, we're using Ubuntu 24.04. Then we install some software, for example, Git, curl, just some common software, and a bit further down, we install the .NET 9 SDK, and all the way down, we also install Podman. One of the advantages of using the agents in Docker container is it's very easy to test something locally. All you have to do is you pull the image and then you have to configure it with a personal access token to access your Azure DevOps server and the URL of your server and also a name. And that's it, and the image runs. If you're interested in how to set it up, I will link a video in the description below where I tell you step by step how to configure it. But for now, let's continue with a bit more of the theory, otherwise we will run out of time. Once you're done testing locally, it's also very easy to run in the cloud. So for example, if you already have an Azure Kubernetes Service Cluster or EKS, you can run it there, or you can also run it with Azure Container Apps, which is in a bit simplified ways a lightweight version of Kubernetes. So Microsoft takes care of a lot of the complicated stuff, and you basically run a container there. The advantage of this is it can be very cheap. You have a free tier, which means you have a lot of execution time for free. So again, if you're a small team, it might be for free for you. What's nice about this solution is you can do scale to zero with Keda. Keda is an open source tool for the Kubernetes event-driven architecture. And if your agent is not running, you scale it to zero, and then you don't pay for the resources. And this already leads us to the costs. Since you can scale to zero and only use your agent when you need it, the costs can be quite minimal. Again, it depends on your setup, but especially for smaller teams, it can be very cheap. The downside of this approach is that you have to know how container work, how to configure the Docker file, how to set it up, how to run it in the cloud. If you don't have an AKS cluster, it might be too expensive to set up one just for your agents. So you have to go with the Azure Container App. But this also leads to some other problems. The biggest one is Docker in Docker. This hasn't been possible in the last couple of years because Kubernetes removed the Docker runtime due to security reasons. And the only way to get it working these days is to run your container as a root user, which is bad for security. And in Azure Container Apps, not even possible. Or there are some tools. Canico was the most popular one, but it has been archived, I think 2 months ago, so it's not maintained anymore. A way around could be Podman, but there again, you need additional permissions. And so all in all, that's not a great solution. And lastly, since you're using a new agent every time, there's again no caching. So to sum it up, it can be, if you have the Docker know-how, easy to set up, easy to test locally. But if Docker is something new for you, it can be quite complicated. And especially with the Docker and Docker downsides, it might not be for you if you're building many Docker images. This could be an interesting solution if you just want to apply some scripts in the cloud. For example, if you have a Terraform script you want to apply to private resources, then you can have an Azure Container App integrated in your VNet and then execute the Terraform scripts. This will be the perfect approach to use container agents, in my opinion. But now we've seen either Microsoft hosted agents running on VMs, running container. Everything works. There's some upsides, some downsides, but there's not a perfect solution. And for a couple months now, we have managed DevOps pools. And in my opinion, that's one of the best services we have on Azure. And it comes with all the advantages of the previous solutions with almost none of the downsides. With managed DevOps pools, we are able to run our agents on VMs, but Microsoft takes care of the VMs. This means we don't have to install any updates, any software. We can use an agent from Microsoft and tell it on what VM it should install the agent, and Microsoft takes care of everything. If this is not enough, we can build our own custom image. This means we create a VM image, install all the software we want on it, but we don't have to install the agent or configure the agent. And once we create the managed DevOps pool, we just say we want to use our custom image, and then Microsoft installs the agent on it and configures it. Since the VM is running in Azure, we can integrate it easily with our own network. Therefore, we can deploy to private resources. This could be, for example, a key vault, a database, and we don't have to have it available on the internet. In my opinion, that's by far the best option we have for self-hosted agents. And since it's so easy to set up, as we will see in a couple minutes, it might even be the best option in general to host our agents. Managed DevOps Pool has been GA since November 2024, so not even a year yet. And if you have experience with new Azure services, then you will know that they often come with some teething problems, and the same happened to Managed DevOps Pools. I found a couple bugs in around January 2025, but all of them have been fixed now. So in general, it's an amazing tool, and there are here and there tiny problems, but nothing breaking, and there's no reason you shouldn't use it. So now about the costs and the upsides, downsides is the big advantage when our agent runs. This means we use VMs, but every time we run our pipeline, a new VM is created. The downside of this approach is we don't have any caching, since every time we get a new VM. And also the startup time is on average around 3 minutes, but Microsoft says it can be up to 15 minutes. So that's something you have to consider when using this. However, the big advantage in my opinion is we can use very powerful VMs and only pay for the time they're running. For example, one of my teams was using Microsoft hosted agents and the pipeline ran for 17 minutes. Now they switched to a VM with 48 cores and a couple hundred gigabytes of RAM, and the pipeline runs for 6 minutes. And they only pay for 6 minutes. I think the VM costs around $5 per hour. This means running the pipeline costs them 50 cents. That's basically nothing, but also such an efficiency increase for the developers because they don't have to wait an hour. They just grab a coffee and the pipeline is already finished. In my experience, the best way to get around this is to have a mix of both options. So I create a new agent, but then I have a time to live of this agent for 5 minutes. This means after a pipeline job is finished, then this agent waits for 5 minutes for a new pipeline job or a new pipeline. And if no new pipeline is started, then the agent will be deleted. If a new pipeline is started, then the agent will pick it up immediately. For me, that's the perfect middle ground of reducing the costs as much as possible because I only pay for the additional 5 minutes of the agent running and waiting, but I also don't have the developers wait for new agents, especially if you have many jobs per pipeline. Lastly, Microsoft also takes care of the scaling. So I can configure how many agents I want to have as a maximum, and then Microsoft will just add more. Keep in mind that the license restrictions of Azure DevOps still apply here. This means if you have a license for 2 parallel jobs and you configure Managed DevOps pools to create 5 agents, then you're still limited to the 2. With this said, I think that's enough of the theory. Let's switch over to the Azure portal and let's take a look how everything works in practice. All right, we are here in the Azure portal, and usually I would recommend to use an infrastructure as code tool like Azure Biceps, Azure CLI, but I think it's easier to show in the Azure portal. If you're interested, I will link you a video in the description down below how you can use the Azure CLI and only a handful commands to create a Managed DevOps pool. For now, if we search on the top for DevOps, we'll find the Managed DevOps pools. Then we can click on Create. And here we can fill out the basic information as with every Azure resource. So we provide a resource group, and down here we have to provide a dev center. But as you can see here, it's still loading something. And that's some of the problems I've encountered lately. That if you don't have a dev center in your subscription, it will load forever. In the past, they gave you the option to create a new one, but now it just loads and loads. Sometimes it works after 10 minutes, but in general, it doesn't work. So now let's create a dev center first, and then we come back to the Manage DevOps pool. So we're going to search for dev center, and we're going to create this. And what the dev center does, it takes care of the hardware in the background. If you're using Azure Virtual Desktop, you already have a dev center, but for the Managed DevOps pools, we are going to create a new one, and then we never have to touch it again because Microsoft takes care of everything. So here we create a new resource group. Let's call it Back to School. Actually, let's call it Azure Back to School. Then we provide a name, for example, Dev Center. The location, just what is the closest to you. For me, it's Canada Central. Then in the settings, we can leave how it is. As I said before, we don't have to touch it again, so we don't have to change anything. We don't need any tags, and then we can create it. So this will take around 3 to 5 minutes. This means I'm going to stop the video here for now, and we'll continue once this is finished with the deployment. Our dev center has been deployed, and if you click here on the Go to Resource, there you can see what options we have. But again, we don't have to change anything, so we can just forget that this exists. Now let's go back and search for Managed DevOps pools again. And we create a new one. And now we can see here the dev center has been selected, but no project has been created now. So we're going to create a new project. We provide a name, for example, Dev Center Project. Going to save this. Now comes the interesting part. So now we have to configure our Azure DevOps organization and the agent. So for the DevOps organization, that's the URL. So in my case, that's programming with Wolfgang. And for the pool, you have to provide a name, and Azure will create a new agent pool with this name in your Azure DevOps organization. So I'm using Azure Back to School. Next, we have the region, again, what's close to me. Then the maximum agents. I'm only using one because I only need one, but here you can set as many as you want, as long as you have the licenses. So for example, if I set here 10, but I only have the license for 2, then it will only use 2. And also we see down here, there's a problem with the quota. So let's take a look at this. In the agent size, we can configure what size or what kind of VM we want to use. So by default, we have a 2-core and 8 GB of RAM VM. But if you want to change it, we can click on Change Size. Here we will have a list of available and not available SKUs. So if the available ones, for example with the D, we can scroll down a bit and we can see here the biggest one is this one, quad core with 28 GB of RAM. If we scroll a bit further down, we can also see here the SKUs that are not available. And if you open one of the big ones, for example the N, and if you scroll all the way down, we can see here with 96 cores and almost 2 TB of RAM, but we can request here the quota. So this will open a new window, and then we can create a new support ticket. Sometimes it's approved automatically, but the bigger the VM, the more likely is that the Microsoft support has to take a look at it. If they have enough resources, then you should get it, and then you can use it. So for now, we just leave it as it is. And once we have deployed our Managed DevOps pool, I'm also going to show you the quota in general, how it works, because by default, it's quite limited. For now, everything is good. Next, our disk. I like to create at least a standard SSD, because SSD is so much faster than HDD and not much more expensive. Lastly, we have the image. This is also something Microsoft changed a couple weeks ago, and I don't understand why, because by default, if we take a look here, it uses the Ubuntu Server 2404 image. But Ubuntu doesn't have developer software installed by default. So if you want to run, for example, a .NET build, it's not going to work. So we're going to delete this, and we click on Add from Image Library. Here we can create one of the Microsoft hosted agents. So the Azure Pipelines Ubuntu 24.4. If we select this one and edit, now we have the Microsoft hosted agent, and that's the image that has all the software tools installed. So I don't know why Microsoft changed this, because if you don't look closely, you just install it, then you run a pipeline, then it will fail. But if you go back to the library, we can also select images from the marketplace. That's mostly just more Windows images and some Ubuntu versions. But all the way on the right here under the Azure Compute Gallery images, we can also have our own custom images. I don't have any, so they are not in the list, but if we created one before, we could just select it here, and Microsoft would install the agent on our image. For now, let's close this. So we have the Azure Pipelines Ubuntu 24.4, and let's go on the next options. So here we can configure if you want a fresh agent or reuse our own agent. For example, if you want to reuse the agent, then we have all the way in the bottom here a new field. And here we can configure the time to live. So that's 7 days. This means after 7 days, the agent will be deleted no matter what. And we can also configure a grace period. This is what I said before, that here you can configure that the agent should live for a short amount of time after a job is finished. And if a new job is started, it will pick up. So for example, here I can configure 5 minutes. This means that the agent will live for 5 minutes if a new pipeline is started. Then the next option we have is we can configure a standby agent. So this is an agent that runs all the time and just waits for new pipelines. I like to have this as off, but you can set it as manual. There you can set a time where this agent should be available. For example, Monday to Friday, 9 to 5. Or you can also set it automatic. And here Microsoft decides when the agents are running. They do some analysis on your usage, use some machine learning, or how it's called nowadays, AI. And you can configure, do you want to be it cheaper and less agent, or just the most performance and pay more? With the slider here, then Microsoft will take care of it. For me, the best solution is to not use a standby agent and just have this grace period configured. But here you can try out what works best for you. Next, we have the network. Here we can easily integrate it into our own network. If you see here, I don't have any, therefore I can't select one. But if I had one configured, I could just add it here. What's important is you have to have the VNet ready, a subnet, and also give the permissions to the subnet and delegate it to DevOps. Again, I will link you a video in the description where I go through this step by step, but it only takes a couple minutes to set it up, and once it's set up, it will just work. So for now, just leave it without VNet. Next we have the storage. Azure VMs come with a temporary disk, but depending on the size of the VM, the disk can be quite small. And here you can add a new storage disk. For example, if I need 500 GB, I can configure the caching. I can configure what type. For example, premium, local, redundant one. Lastly, I provide a drive letter, for example, data. And here you can see I get an error message that a drive letter must be a single letter. That's a Windows feature, not a Linux one. So that's one of the teething problems I mentioned before. So even though I'm using Linux, I have to use a single drive letter. In this case, let's call it F, and it will work. Next up, the security. Here you can use configure our managed DevOps pools to be used in many or multiple Azure DevOps organizations. So if we select this one, we can provide all the organizations we have. I've never used this because I want to limit the exposure, so I use it per DevOps organization. Also, you can configure here if you want it to add to all projects or only to a single project. Lastly, all the way down here, we can configure the permissions. So who is allowed to change it? By default, it's only the creator. This would be me, but I like to set it as inherited permissions from the project. This means all the project admins and the build administrator of the Azure DevOps project can change something here. Then we can add tags, which we don't need for now. And after the validation is done, we can now deploy this. So we're going to create our Managed DevOps pool. This will take around 2 to 3 minutes, and then we can see it in our Azure DevOps organization. While the deployment is running, let's take a quick look at the quota. So if you search on the top for quotas, we have here an overview of all the quota we have. And the quota can vary per subscription, also what agreements you have with Microsoft. But in general, you only have a specific quota. This means how many VMs of a specific type you can use. If that's not enough, you can raise a ticket and Microsoft usually increases the quota. The same with Managed DevOps pools. So if you scroll all the way down with here the Managed DevOps pools, now we have here an overview of all the regions and all the VMs. So if we filter this for the one I've been using, that was Central Canada, I can see here all the VMs I have available, and on the right we can see here I have either 0 of 0 in use or 0 of 5. This means 5 is the maximum I can use, and the 5 means the CPU cores. So if I have a 2-core VM like the one I created, I can create 2 copies of it. This means in total I have 4 cores in use. But if I try to add a third one, I will get an error message saying I'm exceeding the quota. By default, I think it's 5 for all subscriptions, which is very low. And so when you get started, you probably have to increase the quota. So you can do this by clicking on this pencil symbol. Then again, you can set the new limit. And here it depends on your subscription again. Sometimes it's automated and accepted immediately. Sometimes it goes to the Microsoft support and you have to wait. So for me, it's just important that you remember, if you have the quota exceeded error message, then you have to take a look here at the quotas. By now, I think the Managed DevOps pool is finished. Yes. So you can go to the resource. On the overview page, we just have an overview of the usage, how many we have been using, if there are any errors. And on the left side here, we have all the options we configured before. So if you want to change the scaling, we can just change it here and with the same options as when we created it. The only option we didn't have while creating the Managed DevOps pool is this identity here. Here we can assign a managed identity to our Managed DevOps pool, and then we can use this identity in the pipeline to access other Azure services. The advantage of this approach is that we can do an easy login in the pipeline and then use this identity. This means we don't have to create a service connection. A service connection in the end is just a managed identity by itself, but it's created in the Entra, and therefore you need specific permissions in Entra to create it. As a developer, you often don't have these permissions, so this will be an easy workaround. The downside is, if you're using a task that needs a service connection, you still have to use the service connection. So this managed identity doesn't replace it. I hope Microsoft changes this in the future, but we'll see. Again, if you're interested in how this works, I will link a video down below where I will go step by step through the deployment process, and I will also show you how you can use it in the pipeline. For now, let's switch over to our Azure DevOps organization and let's see how it works there. Here in my Azure DevOps, I opened a new project, and first we're going to take a look at the agent pool that has been created. So we click on the bottom on project settings, then we have agent pools. Here we now have our Azure Back to School agent pool. So that's the one the Managed DevOps pool created for us. If we click on it, we can see all the details for the agent pool. We usually see, for example, what jobs it executed, some details, the security, we can set some approvals. For example, I'm only allowed to deploy at a specific time, or specific people have to approve the usage. So that's the same as with all the agent pools we have. Now let's switch over to our pipelines. Here I already prepared one. So let's start this one, and while it's running, let's take a look at the pipeline itself. The first time you start a new pipeline, you have to approve the usage of the new agent pool. So if you open it, we can see here I have to approve it. So we're going to allow it. Now the Managed DevOps pool will create a new VM, install the agent, and then pick up the pipeline. Allowing this is only necessary the first time. So the second time I use it, we don't have to allow it anymore. Now we have to wait for the VM to be installed. This takes, in my experience, around 3 minutes, but it might take longer. While we wait, let's take a look at the pipeline itself. So here you can see it's a very simple pipeline. Let's move this all to the side. The most important part is here on line 6. I use the pool Azure Back to School. That's the Managed DevOps pool I've created before. And if we scroll down a bit, I only execute one Docker task. That's build an image, and I provide the path to the Docker file. I chose this as an example because I said before, with the agents in container, it can be a challenge to build Docker images. And here we'll see that the agent will just pick it up, build the image, and there won't be any problems. Also, if we run our agent again within the 5 minutes, it should take it from the cache, and the second run should be way faster. So now let's go back and let's see if our pipeline is already running or not. So here you can see it's still queued. If we open this, we can see here it's acquiring an agent from the cloud, and it's provisioning the agent right now. So I'm going to stop the video here for 1 or 2 minutes. Once the pipeline is finished, we'll continue. The pipeline is finished, but this time it took 6 minutes to create the VM. This means the developers had to wait 6 minutes plus the time the pipeline took to execute. But we can also see our image has been created. It took 46 seconds and everything worked as expected. But now if we run this pipeline again, then it should take only a couple seconds because the agent already exists and the agent already has the Docker file installed or downloaded locally. This means we should be able to use it from the cache, and therefore the pipeline should execute in a couple seconds, therefore speeding up the process by a lot. Here we can see the pipeline already started. The image build took only 1 second because everything was cached, we didn't change anything, and the pipeline is finished. This also shows why I said I like to have the agent to remain for a couple minutes, because I can reuse it so the developers don't have to wait again, which greatly speeds up the pipeline execution, but it keeps the costs down. That's everything I wanted to show you for today. Now let's switch back to the PowerPoint presentation and let's finish this video. This brings us to the end of my session for today. Today we have seen that there are many different options how we can host our Azure DevOps agents. So on the one side with the Microsoft hosted agents that are easy to get started. For small teams, they might be the perfect solution because they can be free if you don't use them too much. On the other side, we have the self-hosted agents that help us to get around the limitations because we can install all the software we want. We can run it on the hardware or infrastructure we want, but we have to take care of everything ourselves. In the end, we took a look at Managed DevOps Pools, which is, in my opinion, one of the best Azure services we have right now, and it solves a lot of the problems we have with all the other options. In this case, Microsoft takes care of installing the agent on a VM, and we only pay when the VM is running. This allows us to use very powerful VMs and only pay for a very limited time. If we combine the standby agent with the new agent, as we've seen today, we can also create a new agent for the first run and then reuse the agent. This allows us to have a very efficient pipeline, but also keep the costs at a very minimum at the same time. That's everything I wanted to show you. A big thank you to the organizer of the Azure Back to School. It's been a great event, and for you, check out the schedule. There are many great sessions every day throughout all of September, and there's a lot to learn about Azure. With this, I hope to see you next year again, and enjoy the rest of the September.